Today we're working some sample problems from section 2.1 on symbols and terminology. If you're using the online textbook, you may want to print pages 47 through 49. Those are the pages on which the problems will be located. So we're beginning on page 47, and in the first group we have match each set in column 1 with the appropriate description in column 2. And we'll begin with number 2. Number 2 says the set of all x such that x is an even integer greater than 4 and less than 6. Set of all x such that x is an even integer greater than 4 and less than 6. I'm going to use symbols there. Okay, so if we think about even integers greater than 4, that would start with 6, and even integers less than 6 would start with 4 going in the opposite direction. So it turns out we have none, so that would be the empty set, and that is answer G. Okay, let's look at number 4. In number 4 we have ... so it continues on in the negative direction. -5, -3, -1, 1, 3, 5, and A is the set of all even integers. No, those are odd, so let's see if we can find odd. There we go. It looks like it is the set of all of them, so it would be answer D. Let's move on to number 6. This time we have ... -4, -2, 0, 2, 4, ... And it looks like we have here going in the negative direction, -4, -2, 0, 2, 4, and then going in the positive direction. So that looks like the set of all evens. So kind of the complement of what we had in number 6. Okay. 8, we have 2, 4, 6, 8. So those are even integers. And let's see, it's not A. We've eliminated G, D, A. So it's not B. Powers of 2 would be 2, 4, 8. So that's wrong. 16, so 6 wouldn't fit in that. Positive even integers less than 10. 2, 4, 6, 8. Yes, it does work for that one. So it's answer C. Okay, let's turn the page. And the next group says list all the elements of each set. Use set notation and the listing method to describe the set. So in number 10, we have the set of all whole numbers greater than 8 and less than 18. I'm trying to get something here to hold my book open for me. Okay. The set of all whole numbers greater than 8 and less than 18. So greater than 8, we'd start with 9, 10, 11, 12, and how far do we want to go? Less than 18, we want to go up through 17, 13, 14, 15, 16, 17. So we don't include 8 and we don't include 18. 12 is an important one. It helps us to recall what the word between means. The set of all counting numbers between 4 and 14. Okay, so between, again, does not include 4 or 14. So we're going to start with 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, we don't include 4 or 14 there. Number 14, what they want to do is have us list all of those for where the ... dots are. So we have 3, 6, 9, 12. And they want us to fill in all the missing numbers up to 30. Looks like 30 is the last one. Okay, so we're counting by 3, so the next one would be 15, add 3, and so forth, 24, 27, and it would be up through 30, so that's it. All right, in number 16, we have the same thing. I think I'll skip over that one. Let's look at number 20. In 20, we have the set of all x such that x is an odd number, an odd integer between -8 and 7. Set of all x such that x is an odd integer between -8 and 7. An odd integer between -8 and 7. So again, it wouldn't include -8. For one thing, it's not odd, but so we're going to add 2 each time. And we don't want to include 7, so we're only going to go up through 5. Those are odd integers. Okay. Our next group says denote each set by the listing method. There may be more than one correct answer. Okay. And in this case, we can use the ... Let's just look at 22. The set of all integers between -200 and 500. So we'd start 1 greater than -200. So what we want to do is establish the pattern. And then we can do ... And where are we going? We want to go up to, but not include 500. So let's do 498, 499. I think will give us enough of a pattern. Actually, you could just go to 499. You don't really have to put the 498 in there. Okay. Sometimes they make us think about our history, like in number 24. Let's see if we can figure that one out. Let's see if Ms. McCormick can figure that one out. The set of U.S. presidents who served after Richard Nixon and before Barack Obama. So, after Richard Nixon, we had Gerald Ford, don't want a comma in between there, Gerald Ford. All right, and then it was Jimmy Carter, and I'm going to have to kind of list these. And let's see, after Jimmy Carter, we had Ronald Reagan. After Ronald Reagan, we had George Bush. And I think Herbert Walker should go in here. Okay, just to distinguish him from his son. And after George Bush, we had Bill Clinton. And after Bill Clinton, we had George W. Bush. I think I got them all there. You'll have to let me know if I didn't. Okay. Number 26, the set of all x such that x is a negative multiple of 6. So we want only the negative multiple, so we'd start with -6, 2 times that, 3 times that, and so on. Okay. All right, and 28. set of all x such that x is a positive integer power of 4. So what we're thinking is 4 to the 1, 4 to the 2, 4 to the 3, 4 to the 4. And I'm just going to put a few of these in here. 4, 16, 64. I want to say that's 256, and so on. All right, next group, denote each set by set builder notation using an x as the variable.